everybody. This video is about solving systems of equations by the elimination method. Now, the elimination method is really nice. I prefer it most of the time to the substitution method, although sometimes the substitution method is a bit faster, so you do need to know both. Now, this example is designed to use the elimination method. If you'll notice, in this equation, or the system of equations, we have a positive 7y and a negative 7y. Now, without going into all the details of why it's true, you are allowed, when solving a system of equations, to add the equations together. So I can add 2x plus 10x to get 12x. I can add 7y and negative 7y, and those cancel, hence the name the elimination method. Don't forget to add the right-hand side as well. We have 3 minus 27 is negative 24. So just like the name suggests, in the elimination method, you eliminate one of the variables so that you have, well, an equation with only one variable, and then you can solve that. So we have x equals negative 2. Now, just like in the substitution method, once you find one of the variables, you substitute that wherever you like in order to find the other. Now, I think it would probably be simplest to substitute this into the top equation. So we have 2 times negative 2 plus 7y equals 3. Well, 2 times negative 2 is negative 4, so we're going to add a positive 4 to both sides. 3 plus 4 is 7. Divide by 7, and you get y equals 1. Now, just like anytime you're solving a system, graphically, you're finding the point where the lines intersect each other. So these two lines would intersect at negative 2, comma 1. All right, now, this question obviously was designed so that the y variables would cancel at the very beginning. That's not always going to happen, but the elimination method still can be used. So let's look at another one. This one is almost the same. Notice that the top equation has a negative 8y, the bottom equation has a negative 8y. Well, I can't just add these together, because negative 8y and negative 8y is negative 16y, and the whole idea is we would like one of the variables to be eliminated. So rather than add the equations together, what you can do is subtract. That's perfectly fine. So we can say 6x minus negative 4x. Well, please note, 6x minus negative 4x. Be careful of your minus signs. Minus minus will be plus. So that's 10x. Negative 8y minus negative 8y. Again, be careful with the negative signs. Negative, negative, this is plus 8y. So we have negative 8y plus 8y. Those cancel. They eliminate. Then we have negative 22 minus 28. I think that's going to be negative 50. Now divide by 10, and you get x is negative 5. Plug this in wherever you like. It doesn't seem like either one of the equations is going to be all that easy to work with. Well, one's not easier than the other, at least. So I'm just going to use the top equation. So we have 6 times negative 5 minus 8y is negative 22. So this is negative 30. I'm going to add positive 30 to both sides. 30 minus 22 is 8. So we have y is negative 1. So we've, again, found the point of intersection, which is negative 5, negative 1. So this question was still a little bit contrived. We had almost the same thing and just we switched addition to subtraction. So what happens if there's not obviously some variable that's going to be eliminated? So that's what we're going to tackle next. So if you examine what we have here, well, 2x and 10x, adding and subtracting won't cause those to cancel. Negative 4y and 3y, the same thing. So if you've only seen the first two examples, then, well, you're stuck. Not really, though. You've known ever since you started solving equations that one thing you're allowed to do is multiply on both sides of the equation by any number that you feel like. So what I'm going to do is, because I feel like it, and you'll see why in just a moment, I want to multiply the top equation by -5. And remember, if you do that on one side, you have to do the same thing on the other. So the reason that I did this was, let's actually do the multiplication now. So we're going to multiply the left-hand side by -5. Well, -5 times 2x is -10x. -5 times -4y is plus 20y. And 24 times -5, that's -120. So the reason I did this, you can see, is now I have a 10x and a -10x. So if I were to add the equations, together, then the x's would eliminate. So let's do that. Let's add the equations together. 10x plus -10x is 0. 3y plus 20y is 23y. And -120 and -18 is -138. So what in the heck is this? If we divide by 23, let's see. 20 times 6 is 120. 3 times 6 is 18. So yeah, this is -6 when we do the division. So we've solved for y this time now instead of x. That's no big deal. You want to plug this in wherever you want. It doesn't matter. Probably be easiest to plug this into the top equation before we added the green marks, that is. So we have 2x minus 4 times -6 equals 24. So let's see, we have 2x, this is plus 24, so I'm going to subtract 24 from both sides, divide by 2, and we get x equals 0. Just like I mentioned in the last video, 0 is a perfectly fine number. That doesn't mean there's no solution or anything like that. What it means is these two lines intersect at the point 0, -6. Alright, let's do one more example that's about as difficult as the elimination method ever gets. So, what we have here, again, it's another system, and again, you can't just add the x's or subtract the x's. You can't just add the y's or subtract the y's. The problem here is, well, I can't just multiply. Let's focus on this -2x. I can't just multiply by a nice whole number and turn this -2x into a -3x. Now, if you were really brave, you can use fractions. That's allowed, but you do end up working pretty hard if you want to do it that way. In the same way, I can't just multiply 3 by at least a nice whole number to cancel out a 4. So unfortunately, what you have to do is you have to multiply both of the equations by some number. So what you should probably do is pick whichever variable you want to eliminate. It doesn't really matter which, it's about the same amount of work either way. So if we look at the -2x and the +3x, think about what the least common multiple of those two numbers are. Well, the least common multiple of 2 and 3 is 6. So if I were to multiply the top equation by 3, and if I do that on both sides, if I were to multiply by 3, I would have a -6x. So at the same time, if we multiply the bottom equation by 2, 2 times 3x is 6x. So in the top equation, I'll end up with a -6x. In the bottom equation, I'll end up with a +6x. And then we'll be able to add the equations together using the elimination method. So there is quite a bit of preliminary work here. Be careful that you multiply everything and be careful of minus signs. So the top equation, when we multiply by 3, we're going to have -6x plus 9y equals 9. And in the bottom equation, we're going to have 6x minus 8y is -6. And now I'll add these two equations together because the x's cancel. And luckily, 9y minus 8y, we end up with just y. 9 minus 6 is 3, so there's nothing extra to solve for y. Once you get y, substitute this wherever you like in order to solve for x. Again, it's about the same level of difficulty. We'll use the top equation. So we have negative 2x plus 3y, but we know y is equal to 3. So negative 2x plus 3y equals 3. So we have negative 2x plus 9 is 3. So negative 2x is negative 6. And then we have x equals 3. So we found the point of intersection of these two lines, which is the goal. Oh, they intersect at the point 3, 3. So this is the elimination method. Compare it with the substitution method. You do need both. They're both really useful and will be for the remainder of the math classes that you ever take. Anyway, hope this helped. See you next time.